So in this unit, we're going to be talking about chemical bonds, which are the forces of attraction that hold together a group of atoms to make them function as a unit. So overall, we're really looking at the electrons. The electrons are going to be doing different things. So for an ionic bond, they're going to be transferring the electrons between atoms, and then because of the high differences in electronegativity involving metals and nonmetals, there's a strong attraction. And these are some of the properties. They're usually crystalline solids. So one example here of something that you've seen would be something like sodium chloride. It has a very high melting point, and they also conduct electricity. Covalent is the next type. These, instead of transferring, they're going to be sharing electrons between atoms that have smaller differences in electronegativity. So this actually involves just nonmetals. That's an error. Metals are not involved here. Formulas are usually given in the ratio of the atoms. They usually have a low melting point. A few things that you may have seen that are covalent would be something like carbon dioxide or glucose, C6H12O6. There's lots of others. Water is another example of a covalent compound. These two are going to be what we end up spending most of our time on. Metallic is the this one we don't spend that much time on. They're positively charged centers surrounded by a sea of donated electrons. So what ends up happening is the metallic ion, they form positive cations, and the extra electrons are kind of going in between them. So a metallic bond, usually you have just an atom. They have a range of melting points, and it's very dependent upon the number of valence electrons. Common properties include electrical and thermal conductivity. They're very malleable and ductile. So first thing here, we're classifying as the different types, ionic, covalent, or metallic. So why don't you take a moment to try this? What we're doing is we're taking a look at what we have. So we have Na, which is a metal, and Cl, which is a nonmetal, indicating this is ionic. C and O are both nonmetals on the periodic table, so that indicates this is covalent. Fe and I, these are both metals, so this would be a metallic bond. Si, S2, these are nonmetals. This is going to be covalent. Covalent. What we're really looking for are the types of substances we have, and then the last two are going to be ionic. The reason we need to be able to classify these is not only for their properties, but there's also different rules for naming these substances in terms of ionic and covalent naming, which is part of what we're going to be learning in this unit. In terms of naming an ionic compound, we're going to name the cation first, which is or another way of saying the metal part of the ion. And then we're going to name the nonmetal, or the anion, second. The anion's ending changes to IDE. So we have three examples here. We have aluminum and oxygen here. So this is going to be aluminum oxide. BaCl2 is going to be barium chloride. Why don't you try the remaining two on your own? So you end up with calcium nitride and potassium fluoride. So the key here is that the ending is IDE. Notice the name of the beginning part, the cation, does not change here. When we have transition metals, which are the metals in the middle of the periodic table, things change because they have multiple oxidation states, with the exception of silver, cadmium, and zinc. Silver's always +1, zinc's always +2, and cadmium's always +2. But most elements that are transition metals can form multiple cations with different charges, so we use Roman numerals to indicate the charge of the ion. So, for example, if we had Fe plus 2, the name would end up being iron Roman numeral 2. We put the Roman numerals in parentheses to help clarify what they are. And then Fe plus 3 would be named iron 3. So 3 Roman numerals. So if an element does not form more than one charge, then you don't use the Roman numeral. But those are the 3 that we're going to be sticking with are the ones right up here that do not get Roman numerals. Silver, cadmium, and zinc do not get Roman numerals. So the first one, we have iron 3 oxide. So we have Fe plus 3 and oxygen, which has a -2 charge. I can figure this out, the oxygen, because of its location on the periodic table. Or I can also remember from the anions that we memorized. So we have a +3 and a -2. What you're going to do is you're going to swap the charges. So you're going to swap the numbers and drop them down. I call it the swap and drop. So what ends up happening, the 3 is going to go with the oxygen and the 2 is going to go with the iron, resulting in Fe2O3. So this is the formula for iron 3 oxide. So that's one way that we have to do it. The other way that we have to do it is we're given the formula and we have to come up with the name. So here we have lead, some Roman numeral oxide. We have to figure out what that Roman numeral is. So if you look at PbO2, you're kind of doing the opposite. So oxygen, as we said in the previous problem, has a -2 charge, and we have 2 of them. So the way that I do it, I write the charge of 1 on top, and then multiply it by however many I have. So I have 2 oxygen. That's going to give me a total negative charge of -4. So when you have the charges for an ionic substance, it has to add up to 0. So we know then that lead has to be +4, because when we add +4 and -4, it's going to add up to 0. If there were multiple leads here, you would then divide, but that's not the case here. So this is lead 4, which is written as IV. IV is the Roman numeral that you would use here, not 4 lines. That's not the Roman numeral for the number 4. And then the next one, we have iron, some Roman numeral, sulfide. So same process as the last one. We have Fe2S3. So sulfur has a -2 charge. There's 3 of them, so it's going to be -6. So I have to have +6 for iron. There's 2 irons, so we can divide that by 2 to end up with +3. So this is iron 3 sulfide. So 3 lines there representing the number 3. So there's a few practice problems below that you can attempt. So I would pause the video, try naming these substances, and then unpause it to see the results. So here we have the results of the substances. So common things to point out here. So with the iron 3 nitride, both iron and nitride have 3 charges. So if you swap and drop the charges, you would end up with Fe3N3. If you can simplify, just like in math, you're going to. So it ends up being Fen. If you had a 2 and a 4, same kind of idea. So you would simplify that to a 1 and a 2. We don't ever write ones in our formulas because if you write the element, you assume that it's going to be there. And then in this last part, this is kind of just reinforcing the swap and drop, or it can also be called crisscross, so that you can balance the charges. So with this, we have chlorine with a -1 and aluminum with a +3. We end up with AlCl3. And then here's the mathematical formula. If you're thinking of it in terms of math, what's going on with it.